Good afternoon. Welcome to Absolicon webinar series. My name is Carlos Semeraro, Chief Sales Officer of Absolicon Solar Collector. Today, in our virtual studio, we are pleased to host Victor Ruiz from CADE, Spain, Peter Horwath from InSolCorp, USA, and Puneet Saini from Absolicon, Sweden. With our guests are going to have a panel discussion. After that, there will be a possibility for our audience to have a Q&A session with them. Together, we will discuss about the role of heat batteries in the solar thermal industrialization. The importance of thermal energy storage in future energy system with intermittent energy source rely on the fact that heat is half of the total worldwide final energy consumption. Victor, buenas tardes. Can you describe what is a heat battery?
A heat battery is a device used for storing and releasing thermal energy. This heat battery allows a set of thermal energy produced to be temporarily stored and then released at another time for its use. Heat battery can be classified in three different types, namely sensible, latent, and thermochemical. Sensible storage, such as a steel tank, solid-state concrete, and pit storage, happen when a material gains energy when increasing its temperature and loses it when decreasing. Taking the advantage of this property make it possible to use different materials with different thermal properties and achieve various results which can lead to a different thermal energy storage application when the temperature of a material is raised or lowered. On the other hand, later storage such as PCM, phase change materials, molten salts, or even water occurs when a phase of the material is changed without a temperature change. This is important, at a constant temperature. The advantage of using a phase change material is in the way that for a given mass of material can absorb a large quantity of energy without, as mentioned before, changing its temperature. The third mechanism, such as or will be applicable in water with thermocline tank, a chemical reaction or absorption process, and takes place on a material. In all cases, heat can be absorbed or released from the material. As to chemical reaction, heat storage involves a reversible exotherm or endotherm chemical reaction with thermochemical materials.
Thanks, Victor. Later on, you will describe your solid-state concrete and thermocline solution. But now let's go to the other side of the ocean. Peter, which is the biggest challenge that the heat battery is called to solve?
Well, the biggest challenge really is this mismatch between the supply of energy that we have and the demand necessary that we need to provide. And this gets increasingly worse as we add more renewable energy sources, because renewable energy sources generally have specific periods of time when they're very useful, other times when they don't produce as much. It's this interlinking between the heating, cooling sectors and this deployment of thermal energy storage together with an intelligent network technologies that really will be the solution in the future to address this concern between the supply and demand.
Thanks. Puneet, from your experience, which are the request needs from the industries when it comes to heat storage?
Yeah, I mean, as Peter and Victor already emphasized on the importance of heat batteries in solar thermal energy system, I would say a bit about industry expectations. Most of the industry that we deal with wants a higher amount of solar heating share in their process. That's because solar heating can provide low cost of heating compared to fossil fuels, and that's where thermal battery comes into equation, because I think that solar thermal is not a complete solution without heat batteries. This is because either most of the industries operates 24/7, or sometimes they operate with batch processes, and that therefore you always need to store amount of energy that you generate during the daytime. And another issue is, I think what industry really look for is the heat storage in the steam temperature range, because we know that most of the industry use steam as their working media. So we really need to develop steam solutions which are cost effective. And I think one option, an example option could be like steam accumulator with a phase change material that could be charged with a high pressure solar steam. And these options could be short term, so which means storage just for a few hours, or they can be long term solutions ranging from like 15 to 16 hours to up to several days. Some industries are also concerned with the volume of space that this thermal battery require, but I think that with compact storage we can really eliminate that problem. So in summary, the key would be to have a high temperature, low cost and compact storage systems.
From Puneet insights, we are understanding that there are different requests, short and long-term energy storage. Victor, could you describe them?
Yes, the thermal energy storage is used to smooth the difference between the heat load, this is the demand, and the operation of the boilers. Okay, short-term energy storage is used when the energy demand, this adaptation needs to be done in the short terms. This means during cloudy days, or even during the pass of a cloud during the day, during the night, to also to provide heat during the night, or even during the weekend. This depends on how the demand and the factory is consuming the steam. On the other hand, long or seasonal thermal storage indicates for the long-term applications, such as storing a lot of heat during the summertime to be used during the winter time, or in the case of heating, or the other way around in the way of air conditioning, where you store a lot of cold during the winter to be used during the summer. The simplest typical short-term storage is the displacement of cold, hot water via an accumulator tank storage system. Normally, these tanks has a vertical cylindrical form and are made of steel, and they are often located close to the main boiler of the main boiler of the industry. The volume of these tanks is variable and depends on the application, and can go from a few hundred of cubic meters to 10 of thousands of cubic meters. There are two main types of tanks: those working at with a under pressurized conditions, on those not pressurized. This is working at atmosphere conditions. Then, when you are working with a pressurized tank, the temperature can be higher. Seasonal thermal storage have traditionally been tied to solar heat, and allowing the surplus energy in summer to be displaced in the winter period, when the demand is high and supply is low. They are therefore designed to both provide sufficient capacity to absorb that surplus and sufficiently low energy loss over the time to be able to release with a significant share of it later in the year. Four types of large-scale or seasonal thermal energy storage are commonly used worldwide. The four storage concepts are or those typical four are in tank and pit with a thermal energy storage, borehole thermal energy storage, and aquifer thermal energy storage.
Thanks, Victor. Peter, next question for you. Could the heat battery increase the energy efficiency?
Yes, definitely. There's actually two ways it can do that. One way it can do it is by allowing heating and cooling system to operate at their point of most efficiency. The other way is to capture any wasted heat or surplus thermal energy and storing it for later use. Some examples of this would be like, hot water drained down into a sewer, maybe the hot flue gases from a boiler or from a burner, any exhaust air streams, hot or cold gases, waste gases, heat that you can collect from solar panels, ambient outside temperature, bringing the cold from nighttime in the storage system and keeping it for daytime, any heat rejected from condensers and for refrigeration and air conditioning equipment. There's a huge potential here, and these energy storage systems can improve this efficiency, particularly when they're partnered with an intelligent information communication system and energy management system.
Talking about industrial processes, Puneet, what kind of benefits a solar thermal technology combined with a heat battery can provide to a factory?
I think the biggest benefit is that solar plus thermal battery combination can run processes within the factory for extended hours. So which means that instead of just running during the daytime when solar radiation is available, then you can store that heat and then use it for the later purpose. And if you are having a higher share of solar thermal energy into your overall energy mix, then this will lead to higher fuel savings and lower CO2 emission and more economic savings for customers. And as Peter said, that probably it's a really good idea that you use this thermal energy storage to recover the waste heat from condenser and other waste stream within the industry as well. Speaking on the solar collector side, use of solar thermal batteries can help to store the peak solar radiation and utilizing it in the evening when solar production is not so high. And this avoid the spillage of solar heat, making the case more attractive to the customer. So, given these advantages, I think demonstration of such systems concept will provide confidence to industries, so they really don't need to doubt on technical and economic feasibility of complete solar thermal plus heat battery package. And this could be a really good push for industrial sector to adopt such solutions.
Thank you. Victor, the common picture of a battery is the one that generates electricity. Which are the biggest differences between heat and electricity batteries?
Yes, thanks for the question, Carlo. We have a lot of batteries at home and electrical batteries, and we are very familiar with that. The first difference is the kind of energy storage. Electricity batteries store electricity, and heat batteries store heat. If both of kind of batteries are compared for an industrial heat application, the electricity batteries nowadays present a high cost and low productivity because you have a low storage capacity and a shorter storage time. And in some cases, they are too much more dangerous because of their components that compose these batteries, such as acids and leads. On the other hand, heat batteries have proven its availability to store large amount of energy at a reasonable cost, improving system efficiency and system manageability. Moreover, CapEx for electrical batteries, including the battery pack and the balance of the system, can be up to 10 times higher than the current price that we can have with heat batteries. Also, the lifetime of the heat batteries, around 25 years, is longer than the electricity batteries. In a summary, store heat to use heat. Thermal energy optimize energy costs by being directly usable in the process without the need of an additional conversion. With the electrical energy batteries, you will have to do this conversion. So the performance of the heat batteries will be too much higher than the one you can get with the electricity one for, again, a thermal process consumption.
Peter, as we know, solar thermal technology producing a certain amount of temperature can contribute to generate cooling. Can a heat battery be used for cooling application, and how?
Absolutely. I mean, heat batteries basically store heat at a set temperature. That can be a high temperature or a low temperature. A perfect example of this would be ice storage, where air conditioners make ice at nighttime when they have excess capacity, and then use that ice for cooling during the daytimes. There's several companies, successful companies that have been built around this approach. Calmec and Ice Bear is a couple I can think of here in the States. Of course, with ice, there's certain limitations, and ice is probably the first phase change material that was really used quite a bit. But there are some limitations with the ice system, primarily because most of the air conditioning systems are not that efficient at those low temperatures, and by having to drive the temperature down so low to make the ice, you lose some efficiency in the system, even though you do gain on this ability to store and demand shift. This is one reason why most of the efforts of my company and industry really is to develop an ice storage system at, say, 4 Celsius to 15 Celsius range, which would be perfectly ideal, because in this range you can actually operate your cooling system at the most efficient points and store energy at the same time, giving you both an increase in efficiency and an increase in being able to address demand issues.
Coming back to industrial cases, Puneet, how would you balance the heat supply and demand, providing a free CO2 factory?
Yeah, I mean, zero CO2 factory is something which is actually getting very popular, especially among multinational, because they on an annual basis they really want to achieve carbon neutrality in their process. And if you look at the energy breakdown, then you will see that most of the energy they consume is basically in terms of heat, not electricity. So what we need to achieve, or what is critical, is to achieve the carbon neutrality in the heat demand. So I'm going back to your question, how to achieve that. I think what we need is a combination of several low carbon technologies, and solar thermal is definitely the key, but there I can see some other technologies, probably PV driven heat pumps, etc. And these technologies should meet a bigger part of the heating load. Until now, solar thermal is widely implemented for industries. We have so many projects that have been realized, but one bottleneck which always remains is the solar fraction, which is the amount of heat that you can meet using solar thermal. It's usually below 25% for most of the installations. And the reason is that we have lack of heat battery solution for steam temperature, and that's the most widely used working media in companies. So if we have a heat battery, then it is possible to meet a very high solar fraction, sometimes up to 90% using solar thermal, and the rest can be met using other low carbon technologies. So the overall package can provide a solution which can generate negligible CO2 emissions compared to fossil fuel.
Thanks, Puneet. Let's have a short overview of the last solar thermal projects signed during the last weeks. Heliogen, a US company, started a cooperation in the mining industry in the US to decarbonize the processes. As last month, also in March, Savo Solar has green news regarding new solar district heating project. If last month was in France, this month Savo Solar won a tender to build a solar district heating plant in Germany. Last but not least, Green One Tech announced that the first construction phase for the project in Austria has been completed. We can see a big heat battery installed on the field. Great news from solar thermal companies around the world, both from solar industrial processes and district heating application. Puneet, the usage of solar thermal storage in district heating networks is historical. Can you give us some insights about it?
Yeah, I mean, I think it was around 1930s which is considered as start of a second generation district heating networks, when combined heat and power CHP plants were introduced to supply the heat for district heating. And this brought a reduction on the temperature level, and this reduction of temperature enabled to have a higher energy efficiency in the whole system. But I think one important thing which come with the reduction in temperature was the possibility to bring solar thermal or other renewable heating into the complete district heating networks. And many of the projects with district heating has been realized, and especially countries like Denmark or Germany, and few projects in China are now being commercialized as well. And the heat batteries that these district heating system use is called seasonal energy storage. So because they basically collect the heat during summer period and then they utilize it for winter period when the heating requirement is the highest, and the capacity is immense. I mean, we have seen the commercial projects up to 125,000 cubic meter capacity, and now there are new research projects which aim to increase the capacity by 10-folds up to few millions meter cube. So we have already seen, and I think we will see very low cost of storage with these very large seasonal energy storage systems.
Thanks, Puneet. As we can see, heat battery has been used since decades. Victor, which is the market maturity of your technology, and can you describe it briefly?
Yes, currently, as a clear example is this presentation, we are in the process of energy transition towards a generalized use of renewable energy compared to the historical use of fossil fuels. Consider that the thermal storage plays a fundamental role for decarbonization. It is true that some of these technologies have been used for decades, but still the technology is susceptible for being improved through research and development action. And this is something we are continuously involved in CADE. Okay, the thermocline water tank is a very mature technology. I think all of you have proved this technology because many of you should have one of them at your home. Okay, because the heaters that you use for your water at home probably are using one tank of this thermocline configuration. The idea is to apply this configuration to a larger scale in order to cover the necessities of the industry. So it is just a question of applying a very mature technology to a larger scale. The problem with this configuration is that the water has vapor pressure, and for temperatures above 200 centigrades, the pressure vessels that you need to store this water will have a heavy wall, and for this reason they are not very competitive in terms of price. This is the reason why in CADE we have developed another way of storing the energy, that it is based in solid material. This is what we name the solid test. This is technology that it is has been used for or has been demonstrated for a long time ago, but that it is now getting more into the market. We have a pilot scale project with a capacity of 800 kilowatts hour storage capacity in an industrial facility in Cyprus, operating during 3 years with a very good continuous results. Okay. Basically, the thermocline tank is a tank with an special diffusers and configuration in order to have a plug flow temperature condition inside them to ensure that there is a very good differentiation between the hot area and the cold area. And on the other hand, the solid test is a block of concrete with a bundle of tubes inside where the heat transfer fluid that can be water, molten salts, or an oil HTF move in one direction or another, charging or discharging the element.
And Victor, which kind of benefit your solution?
Yes, with this solid test, we can go with a very high temperature of up to 500 centigrades with a very good thermal efficiency.
And Victor, which kind of benefit your solution can provide to energy systems that require heat from 80 to 200 degrees?
Normally, those industries that require heat from 80 to 200 degrees, make use of technology based on fossil fuels, as mentioned before. Therefore, the first kind of benefit of heat batteries is environmental and economical because of the CO2 emissions derived from fuels are removed by using this technology. Besides, as this technology does not require the use of fossil fuels, the initial investment is recovery in few years, so that the heat batteries are more competitive in mid-term. In this temperature range, one of the best thermal storage solutions would be the water thermocline tank, as explained before. This system is based on keeping the stratification of water inside the tank during the different operational modes, charge after charge. This system is based on storing heat in water, taking the advantages of its properties, such as a very high heat capacity, which means that you can absorb a huge quantity of energy in a very short volume. On top of this, the water is a very common and safe element.
Thank you, Victor. Peter, which is the market maturity of phase change material system, and can you describe them?
Yes, I would say we're probably in an early commercialization stage. You know, as I had mentioned previously, ice storage has already made some penetration into using phase change materials for demand issues. And there's several companies out there now that involved in developing phase change systems for low temperature, as we are ourselves, and have prototypes and projects working. We are also, my company, InSolCorp, we're actually involved pretty heavily in warm temperature energy storage right now in the 36 Celsius to 72 Celsius range. And that's primarily on, storing hot water for hot water demand issues. Taking solar, for example, and heating hot water for, applications where it seems like the most of the demand is in the morning. We're also really at a stage now where most of the work left is engineering more than it is scientific or research. I mean, we have many good phase change materials developed in these ranges, and we understand heat exchangers and other things to the point where it's basically just finding a project and doing the engineering around it for a solution. So we're at a point where we can already provide solutions out there, but the industry doesn't really have that much education yet as to what's available to them.
And which kind of benefit your solution can provide to energy systems that require it from 80 to 200?
From 80 to 100, I mean, the real benefit really is this ability to be able to peak shift. I mean, heat batteries are probably the most efficient way to address this problem that the sun only shines half the time of the day, and the energy you can produce with it is limited to those 12 hours where the sun shines at that point. So we are, the real benefit is being able to take the benefits from these wonderful renewable energy sources and spreading them out across time so that we can meet this demand use.
So, Puneet, do you have any final comments?
Yes. Again, my message to industries is that solar thermal in combination with heat batteries is technical and economically feasible solution. And as Peter and Victor said, like, we have storage solutions for wide range of temperature range, and they are getting cost effective. And even internally at Absolicon, we are trying to adapt these existing solutions into industrial heat networks and try to provide a standardized solar thermal plus heat battery package. And that's in collaboration with other industrial suppliers, heat battery suppliers. So yeah, don't hesitate to contact us in case you consume heat, and looking forward to have a low carbon and sustainable heating solution.
Thanks. And the Q&A session is already ongoing. We received the first question, and the first question is for you, Victor. Instead of storing the heat in a 100,000 liter storage tank, can one use 5 its storage per 20,000 liter storage tanks connected in parallel?
Okay, Carlos, thanks for this question. Yes, the answer is yes. In fact, it is more reasonable to use these 5 tanks than to use only one, okay? Reason behind this is that you need to be, because since we would like to have a very clear stratification between the hot and the cold area of the tank, we need to have tanks that are very high compared to the diameters, okay? So when you go, if you try to design a tank for a capacity of 100,000 liters, you need a height that can be even above 20 or 25 meters, and that has no sense, okay? So it is very reasonable and will be the solution to use several tanks working not only in parallel, but also in series, depending on the application. But yes, the answer is yes. Total capacity should be split.
The second question from our audience is for Peter. Are heat batteries in organic phase change materials?
Excuse me, can you repeat the question? The batteries in organic phase change?
Inorganic phase material, but I think that the question is, do we have inorganic and organic PCM?
Yes.
This is the meaning of the question, I think.
Yeah, we have organic and inorganic PCMs. There's advantages on both of them. The organics it's easier really to develop specific temperatures with the organics, although that's now changing as more research is going into inorganics. But the inorganics have a much higher energy density because they're much more dense materials, and they're generally much less expensive, and they also have better thermal conductivity. So the future of energy storage will most likely, other than a few areas where it's preferred, go towards the inorganic route. But both are available.
Thank you, Peter. The last question from the audience is for you, Puneet. Is more the tricky one. How competitive are the heat batteries regarding the investment cost?
Yes, that's the trickiest one. That's true. I mean, it always depends on what you're really replacing, that like what fuel you're replacing in an industrial network perspective. If you're replacing oil or diesel, which are quite expensive, and then you are using heat in the heat batteries from solar or other low carbon solutions, and then the cost competitiveness is really good, I would say. But these solutions are getting cost effective, and especially in district heating, where we implement really large scale peak storage solutions, we have seen cost as low as 30 euros per meter cube, and which is 0.3 euros per kilowatt hour. So like I think these solutions are getting more and more cost effective, and with future, I think with learning curve we will reach at a really good stage.
Puneet, Victor, and Peter, thanks a lot for your time and interesting insights. I wish you a good Easter with your families, and see you soon in the next Absolicon webinar series to you. I hope that you follow us and also our audience.
Thank you, Carlo.